Okay, this video is to explain the idea of displacement, and we're going to start off with one dimension. The particle or object can only move in the x direction, either positively or negatively. And let's say, for example, that an object starts out at position 3, and by the way, these can be any units you want. It could be meters, it could be feet, it could be miles, whatever, but let's say that the initial position, which I'll refer to as x initial, like that, x sub I, is 3. And let's say that I move over this way to, let's say, 7, and I'll say that's my final position, x sub f. And how far have I gone? I went from 3 to 7, that's 4 units. So this over here is 4 units, but I call this delta x, meaning the change in x, where this is equal to xf minus x initial, and that is equal to 7 minus 3, so that's equal to 4 plus 4, because I moved in the positive direction. But let's say that instead of x final being 7, let's say it's something else. So I'm going to call this one x final number 1. But let's say instead of stopping here at 7, I moved out to 7, but then I came back to 5. So let's say this one right here, x final 2, is equal to 5. Now the displacement is equal to x final minus x initial, so that's equal to 5 minus 3, which is equal to 2. Again, I still have a positive displacement of 2 units, although I went actually out here to 7 and came back to 5. But the displacement is just simply the final position minus the initial position. Well, let's take one more case and say that I went out initially to 7, it doesn't really matter, but I came back to 1. And let's say this one is x final 3, let's say. That's x final 3. So delta x, the displacement, is equal to the final position, x final minus x initial. So that's equal to 1 minus where I started, which is 3, and that's equal to minus 2. In other words, my displacement from my starting position is minus 2 units. In other words, it's negative in this direction is where I ended up. Now, the amount of distance I traveled is different in each case, but the displacement is what's called a vector, and in this particular case for one dimension, the vector nature is contained within the sign. In other words, if it's plus, then it's to the right, and if it's negative, it's to the left. There is one additional thing I wanted to mention while we still have this diagram here, namely that just because I ended up at this position, position number 1, which is a positive number, the displacement is still negative. In other words, it's the displacement from the starting position, which is in the negative direction. And just to thoroughly make the point, I'm going to take one more case. Let's say x final 4, let's call it, is going to be equal to, say, minus 4, for example. Let's just pick that, minus 4. This is x final 4. So delta x is equal to x final 4 minus x initial, and x final 4 is equal to minus 4 minus x initial, which was 3, and that's equal to minus 7. So in other words, I actually ended up 7 units to the left of my starting position. 1, 2, 3, 4, 5, 6, 7. So if you'll just stick to this definition, it always works out correctly. Okay, now I said just a minute ago that the distance traveled is different than the displacement, and that's what I want to make clear here. If we go back and look at the original displacement, we went from x equals 3 to x equals 7, and the displacement was 4 units. And then I said we went from 3 to 7 and then back to 5. So the displacement ended up being positive 2. However, the total distance we traveled was 4 plus 2 was 6 units. And that's the distance traveled, which is different from the displacement, and it's important to keep that in mind. For example, in the last case, let's say I started at x equal 3. I went out here to 7, that's 4 units. I came back to here, that's 7 plus 4 more, that's 11 units. So the distance traveled is 11 units, but the displacement is only minus 7. And it's very important to keep that in mind because we're going to define what's called the average velocity. Oftentimes a bar over a V represents average velocity. And that's going to be equal to delta x divided by delta t, where delta t is equal to t final minus t initial. A lot of times t initial is going to be equal to 0, and a lot of times x initial is going to be equal to 0. T initial, x initial equals 0, and then you would just say that the average velocity is equal to x over t. And here's where you need to be careful, because this is not the distance traveled, this is the displacement. On the other hand, if indeed you use the distance, then we refer to this as speed. We can write it average velocity, but you have to be careful with it. Just call it speed. And the speed is equal to the distance, sometimes denoted by the letter s, divided by the total time. So that's the speed, which is quite different than the velocity. So just to summarize, the displacement, delta x, is equal to x final minus x initial, and the average velocity is equal to delta x over delta t.